Okay, I would like to go over an example similar to quiz number 3, problem number 1, right? So it's a limit problem, right? So when you try to evaluate a function, so for example, like f of a, then we're talking about real actual value. So this is going to be a actual value of the function, right? But when we are talking about limit, limit is the tendency of the function around x equals 1, right? So, for example, let's look at this graph here. So this is a graph of y equals f of x, right? Then we're trying to evaluate this function at 1, right? So this is an actual value. So if you go to exactly equal to x equals 1 here and go up, and you see that there's a graph right here, right? So then you read the y value, so that's going to be 1 here. So function value is equal to 1, right? But on the other hand, the limit, so this one, because of this negative sign, it's a left-hand limit. So you're approaching 1 from the left, right? So 1 is right here. So you follow the graph, you're approaching x equals 1 from the left. You can see that the tendency of the graph is heading toward this point right here, right? So you go to the right, go to the y-axis and read the value. So that's gotta be 3, right? So the tendency is heading toward 3 if on the left, right? But the right-hand limit, so we have to follow the graph coming from the right. So you're following this graph, and x gets closer to 1. You're heading toward this point right here. So which value, corresponding y value would be 1. So the right-hand limit is 1 instead, right? When left-hand limit and the right-hand limit give you different values, right? If that's the case, the both-sided limit, the regular limit, does not exist. So you just say DNE for does not exist. All right? All right, so let's look at another example. So let's say x is at x equals 3, right? F of 3, right? So this is f of 3, just the actual value. So x equals 3, go up and find the graph and read the corresponding y value. So that will be 4 there, right? So f of 3 is 4, right? When you look at the tendency of this function as x approaches 3 from the left, so let's look at that. So from the left, so you can see that it's heading toward this point, which has a corresponding y value of 2, right? So left-hand limit is 2, right? And the right-hand limit is, let's say you're coming from the right, then heading toward actually the same point, so the corresponding y value is 2, right? When left-hand limit and the right-hand limit agree with each other, and it gives you exactly the same value, then regular limit is going to give you the same value. All right. So the difference is all we really have to know is whenever you have to evaluate a function like f of 1 or f of 3, we're looking for the actual value. So you just go to that value and look for the graph and read the corresponding y value, right? But the limit is a tendency. So you look at the tendency of the graph, which point it's heading toward. Then you can determine the corresponding y value from there. And if you have a negative sign here, this is a left-hand limit. So you approach from the left. If you have a positive sign, it's a right-hand limit. It approach from the right. All right. If you have no sign, it means that you approach from both sides. So you have to look at the left-hand limit and right-hand limit. If they are different, then the limit does not exist. If I give you exactly the same number, then that number is going to be the limit. All right, that's it. I hope that this was clear.